Okay. So here's a question. An atom loses 2.5 electron volts of energy as it emits a photon of light. What's the energy of the photon emitted? You should take 2 seconds to answer. 2.5 electron volts. If it produces 2.5 electron volts, if it loses 2.5 electron volts, so it loses 2.5 electron volts, that 2.5 electron volts is carried by the photon, right? What's the wavelength of the light that's emitted? How do you calculate lambda? Okay, energy of the photon is hc over lambda. So how do I solve for lambda? hc over E, photon, right? So what's h? 6.626 times 10 to the negative 34 joules second. C is 2.998 times 10 to the 8 meters per second. What's the energy? Yes, 2.50. Electron volt is, I can just substitute here. An electron volt is 1.602 times 10 to the negative 19 joules. Quick conversion right there. Because when you say 2.5 electron volts, that's the same thing as 2.5 times electron volts. All right, so joule cancels out, seconds cancel out. This will give you your answer in meters. What's the answer? 6.626 times 10 to the negative 34 times 2.998 times 10 to the 8th divided by 2.5 divided by 1.602 times 10 to the negative 19. Oops. Negative. 19 negative equals 4.96 times 10 to the negative 7 meters. So what would that be in nanometers? 496 nanometers. What color of light would that be? 500 huh? Yeah, what color? Visible, yes, but what color? Green. Green. 500 is green. Okay. So you have a spectral line in the absorption spectrum of a molecule occurs at 500 nanometers. What's the energy gap between the two allowed energy levels? Let's make that homework. Turn in next time. Okay. And then this one, what's the answer to this one? This is an easy one. 3 lowest allowed levels are 0.5, 1.5, and 2.5. So 0.5. So that's 1. 1.5 is allowed. And 2.5 is allowed. The 3 lowest levels allowed. Let's say you have a particle with an energy of 0.5 electron volts right here. It will not absorb a photon with energy of what? 0.5 plus 0.5 will only take it to 1, so it will not absorb A. Okay? Will it absorb 1 electron volt? It may absorb 1 electron volt. Depends on what the selection rule is. Will it absorb 2 electron volts? It might. It may absorb 2 electron volts. Okay? It's not guaranteed because we don't know what the selection rules are.
Are we going to learn the selection rules?
Yes, later this semester we'll learn the selection rules.
Not before this first exam.
Then at this point all you can say is may or might. But it's not forbidden, let's say, by the Bohr frequency condition. It could be forbidden by the selection rule, but not by the Bohr frequency condition. You know for sure it's not going to absorb 0.5 electron volts, right? But you don't know for sure whether 1 or 2 electron volts would be accepted. This one right here, A4A, 9A, 16A, those are the lowest allowed energy levels. What would be, let's make that another part of your homework. The homework, it's question number 2 for your homework. And this one, you should be able to do this if you want to. Your allowed energy levels for the hydrogen atom is given by this formula. So what's the lowest energy? For n equals 1, negative 13.6 over 1 squared, so negative 13.6 electron volts. That's the lowest energy. What's the second lowest energy? En equals 2, so negative 13.6 electron volts over 2 squared. What would that be? Negative 13.6 over 4, right? So if this is negative 13.6 right here, this is E1, where's E2? Let's put 0 over here. So a quarter of the way between 0 and E1, right? So it's E2 right here. Where's E3? Quarter of the way, 1/9 of the way, right? So E3 would be negative 13.6 over 3 squared. So that's 1/9. So this is 1/8, so 1/9 somewhere here. So E3 is over here. Okay. So let's say you have a hydrogen atom that has an energy equal to E1, which is negative 13.6 electron volts. Which of these photon energies cannot be absorbed, okay, by the hydrogen atom? Can it absorb 5.1? 12.1 or 13.2? Which of these cannot be absorbed? You have to figure out what E2 and E3 are. So if you have 5.1, what would it be? Looks like I just gave you the answer. 13.6 plus 5.1, what would it take it to? (13.6 plus 5.1) negative 13.6, right? Okay. 13.6 negative plus 5.1. It will take it to negative 8.5. Where is negative 8.5? Somewhere over here. So that would not be allowed. So 5.1 cannot be absorbed. You know for a fact right away based on the Bohr frequency condition. Okay, 12.1 and 3.2 must take it to where? You can figure that out. It's probably going to take it to E2 or E3. If there's only one correct answer here, then the other two must take it to some allowed level. Okay, whether that level is actually, whether it's going to be actually allowed, again, depends on the selection. And it turns out it is. That red light that you see, this is actually going to happen in the ultraviolet range. Okay, that's if you remember your orbitals from freshman chemistry, that's going to take it from the 1s to a 2p orbital. Okay, and that red light that you saw in the spectrum of hydrogen, that's called that's the first in what you call that series of lines you see in the visible spectrum. That's called the Balmer series. That actually goes from the 3rd level to the 2nd level. First one, the red line. Okay, and these are again resources for you to look at for more on this. Okay.